All right, can everybody hear me out there? All right, my name's Troy, and I am currently in charge of Workstation and long-haul stress. And today we're going to discuss what is involved in stress. So this is kind of the overview of what we're going to talk about. What is stress and why do I care? Workstation stress. This is going to be the basics from a user side of it and a little more in-depth on behind the scenes of someone who would actually own the stress server, which I'll get into more. Component stress. We'll get into this. Long-haul stress and what is it? We will discuss that. All right, so why do we run stress? To simplify it, we use this to determine the health of a system. When we're running on say service pack, we're testing service packs. Every day a new build comes out, and we want to run this stress. Stress is a known set of tests that's going to really just load your PC to the max and try to find any breaks anywhere it possibly can, whether it be user mode, kernel mode, bug checks, whatever, you name it, driver problems. We just try to catch anything and everything. Like I said, it allows us to load the system to the max. Most component testing, you don't do this. You test one specific component. Stress is a lot of different components being tested at the same time, and really bogging down your system. Some of the older systems, you can barely even tell what's going on because they're so slow with all this going on. Stress apps, they're not just a typical test you may do for your component. This is going to be something that is known to pass and will always pass. We don't want to use stress to try and do your testing for you. We want to do stuff that we know always passes to make sure it doesn't fail now. And we don't necessarily want to break it with a bunch of false data. So that's why we want well-behaved apps. And the sheer number of these apps, these stress tests running at the same time, helps us find issues that we couldn't normally find. If you were, testing directory services, you may be testing one particular thing at one time. But now, if you take everybody who tests many different apps and put all their stuff on the same system and run, you're going to have a better chance of finding problems that you wouldn't normally find with just your component level testing. Why do all of us do this? The reason we do this is the environments we have are very complex. You take a user environment out on the real world, and it's tough to duplicate exactly what they have here. Say in a lab. If we're going to do something in a lab, it's going to be one configuration, and that's it. It's going to be tough to get every single combination. So if everybody out there who has a machine sitting in their office starts stress up at night, they have different things that they've done on the machine during the day that could load the system to a different configuration. And that's kind of what I'm talking about here. The different types of install methods, maybe for the service pack, we install them in different ways. We have different cards, let's say PCI cards. You may have a modem in one of your systems in your office that we wouldn't necessarily have in the lab. All these different things. That's why we need everybody and not just a lab. Exactly what this says here. It's impractical and too limiting. It's tough for one person to be able to replicate what all of us can do together. So collectivity, that's what solves the problem. All of us doing the work together. If we all do 2-3 machines, we could easily get over 400 machines per night running stress. Our goal is 300 per night at least when we're really pushing to test a service pack. And does it really work? So this is some of the data for Service Pack 3. There were 1,800 code defects in Service Pack 3, 150 of these from stress. 60 of them were fixed. One of every 30 code defects fixed in SP3 was from stress. So it really does work. WinSE break is a database of bugs, and this is some of the information when I last collected this data. We had 2,275 breaks. 540 were either new bugs or existing bugs. A new bug would be the developer would say that this is a new issue, open it in our real database. We kind of keep this database as tracking of stress, and if it actually is a new issue, then we put it in the Project Studio database. So let's say for SP5, it would go in the SP5 database as opposed to this WinSE break database. So that means 1 in every 5 breaks filed is a real bug. 130 breaks resolved as new bug. So that means we're finding a lot of issues. 1 in every 20 breaks that stress encounters is a new bug. All right, so this was brought up last time when we did this presentation, that it was a little unclear how everything was related. So over on the far right, we have a stress server, which is owned by the stress team, and this is where all of our machines are going to connect and send data to. The machines I'm talking about are these clients down here in the lower right, the stress client. That's going to be something sitting in your office or the lab or wherever, and it's going to have a debugger connected to it. It's a kernel mode debugger. It's got a debugger cable. Your dev box really isn't involved in stress at all in this scenario here. They're all just connected, kind of the same network, and this is how they work. Option 2 is, if you don't necessarily have a debugger, you can use your dev box as a debugger. You just simply connect the cable up. This is how I do it in my office. It helps limit the number of machines I need in my office. All right, so from the stress client down here in the bottom, you're going to run this command. This is the command we use here. I don't know what it will be when we send it overseas, but what this does is it's going to copy some basic stress apps and launches the stress sign-on dialog. The stress apps are, like I say, your component tests that you want stressed every single night. And I'm going to show little snippets of this further along as we go. The stress sign-on dialog then launches the stress manager. Stress manager starts the stress apps and keeps registering with the stress server. This is like kind of a heartbeat that lets the server know that I'm still up and running stress. After log off, relog in, the stress manager invokes cleanup. So it's going to go through and delete all the apps that were copied down locally and try to clean itself up as best as possible, so that you could use it, without having to rebuild the system. This is the stress sign-on dialog. As you can see, the email name, that's going to be important for when if we detect as a stress team that your machine is broken, we're going to be able to contact you via that email name and let you know that your machine is broken and what to do next. The office number is like where the machine is physically located. Sometimes there's issues and we actually need to go straight to the machine and figure out what's wrong. The debug machine name is really important because before stress will even start, your stress machine is going to try to connect to the remote debug window, and if it cannot connect, then it won't allow you to run stress. We do this because we don't want a bunch of machines without debuggers, because if they break, it's a waste of our time if we can't actually debug them. We're testing for no reason really if we can't determine what the problem is. The stress directory is not important. That's just, you could change it, but by default it comes up on its own. That's just where it's going to copy the local apps to and where it's going to get cleaned up from later. Symbols, if you have symbols copied down locally, this will help for debugging. User mode breaks, you need symbols on the local system, so on the stress client, because a lot of times when you break, you're not going to have network access to access a remote share. A lot of these other options we pretty much just leave as they are. Encrypt, enable compression. These are for different types of testing, and certain people use them, but for the common stress participant, we don't touch them. The type of stress, sometimes we create different groups for different reasons. There may be some network tests maybe that are really network intensive that we don't want everybody to run, but maybe you want to run them since you're the network team. So in that drop down, you could drop down to a different group and run the tests within that group. But for the most part, we just leave that as default as well. Scheduled shutdown, that'll log you off in the morning so that the machine is ready for you to test on. It'll just take care of it automatically, unless the machine is broken. If it's broken, then it won't log you off. It'll stay broken so that someone can debug. And then the private will get selected if we can't find your debug machine, and we will not count you in the stress results if you have private selected. A lot of times you may be testing at private from a developer, and you want to run stress on it, but there could be issues with it, and you want to debug them yourself, so you kind of take it out of the main stress. You select this here to check private, so you're still running the regular stress, but we're just not going to look at your machine if it ever breaks. This is the stress manager. This pops up shortly after you fill in that last screen. Again, we have the NT group selected. By default, there's a certain number of tests selected over here. These are all different tests that different groups have come up with, and they all do different things. Over there are additional tests. So this is the default, and then those are additional. So you could select. Those ones are set to manual, and I'll show you that in the stress this a little bit further down. But they're manual for whatever reason. It could be decided that this isn't something that we want everybody to run, but maybe you want to run it yourself, so you could grab it and move it over here, and then it'll run. You hit go, and stress will start. The stress INI is what creates all basically from that UI that you just saw with all the different tests and that kind of stuff. It's a single file describing all of the stress apps. It's organized into 3 hierarchies: stress types, test groups, and tests. Stress types are broad classifications which comprise test groups. So like NT was a stress type. There's some other German, for example. When you start stress and we detect your machine is running German, since we test English and German here, we're going to change your group to German. The group is exactly the same as NT, the actual tests inside of that group, but it lets us know from the stress side that you're running on a German machine rather than an English machine, so we can separate the results. Test groups, as it says. So inside of NT, you may have some different test groups like GDI, which are going to comprise of all these different tests: the GDI 16, GDI 32, OpenGL, etc. It also specifies the minimum and maximum numbers of tests. The tests that were on the left side, there was so many selected, then that's where this minimum and maximum comes into play. It depends on your system. If you have a really low amount of memory, we're not going to select very many tests for your system to run. If you have a lot, we're going to try to max it out. That's where the min and max comes into play. And then tests are the actual just individual tests, whatever that may be. If you test RAS, you may have some sort of dial-up application that runs. This is an example of entry. This is the test. This is where I was saying it was manual. If you uncomment this, then it would not run by default. You'd have to select it from the right-hand side and move it over. And this is a lot of information that this is kind of behind the scenes of stress. That if you're just running stress, you don't need to know too much about this. But it's just this just tells a lot of information to the stress manager of what to do, where to get the file from, how to execute it, that kind of stuff. It gives us a contact, so we know if this test breaks, that we can contact that owner. This again is just to show how you can move from the blue to the red if you want any of those additional tests moved, or you could take some out of the red. There could be a test that's causing a failure every time on your machine for whatever reason that you may want to take it out. Or there may be something that you really want to test that you want to add in. Stress Manager, it does a randomized test selection. So it's going to try to go from min to max, find out how many tests it can run, and then kind of randomly select tests in there so that each system gets a different set of tests. Again, the additional test contains the manual only. There's a group called last run group. This is if you just run stress and logged off, or maybe your machine broke and now the developer's done with it and said, can you repro this? You could select this group and it's going to rerun exactly what it ran on your system last time. A minimal set of symbols are also going to be copied. We try to copy symbols for all the executables that maybe get downloaded to your system as tests, so that if a test breaks, we can debug it. This is the server side here. This is what we see on a daily basis of the registration. So these are all clients out on the network, and they've run that stress.cmd, and they've now synced up, and you can see some of these machines are dead. They all have all the different colors mean different things, and then we have a nice little summary. This app really just creates a comma separated value text file. which is where our main reporting comes into play. So we don't look at this app a lot. It's just running on the server all the time. The CSV is parsed by a VB script, which creates XML, which creates our main reporting site. So it went from this to a web page, and there's lots of different reports that we can go to, and we can get into that more later. This is when we're triaging as the stress team. Now we go in the morning after a night's run of stress. We load up this Access database and start walking through this form, and it's going to tell us all the machines that are broken. What we have to do is get the remote to your debugger and connect to it, and then we check out what's wrong with it. In this case, there was an unhandled exception. We do a few debug commands, get the symbols loaded correctly, all that kind of stuff. We paste this in here. We can assign it to a specific person to follow up on. Today, what we would do is assign this to an alias called SP Break, which is Service Pack Stress Breaks Resolution. It's a team of developers that they get email when this happens, and they go look at this. Whenever it's assigned SP Break, we automatically file a bug in the WinSE Break database. So in this case, this one should be. Back in the day, we used to have to tell people to open the break, but now we actually do it for them. So this is an older picture, but it still serves the same purpose. So these are some of the common replies we give to people when we're debugging. Unable to break into the debugger is we can connect to the machine, we can see the debugger, but we're not able to break in and do anything to your system. There's something wrong. A lot of times you may rebuild your stress machine and not enable debugging. You actually have to turn that on so that the two machines can talk to each other. If you don't turn it on, we're not going to be able to communicate with that machine. So that's where unable to break into debugger may come into play. And a lot of times it could just be that the remote is just gone bad. You just need to close it and restart it, and we're able to connect. Unable to connect just means we can't even get to your debugger. That could be username problems, IP address problems, anything. You may not actually have the remote running using the proper name. Bad symbols, because everybody's running so many different variants of stress. They have different service packs installed, different hot fixes from Windows Update installed. We need to make sure we have all the symbols correct. So a lot of times if we can't figure it out, we're going to just tell you guys to figure it out. We're going to put in there as bad symbols. The next line in there, when would I need a symbol CD? If you get a user mode break, which I was talking about earlier, you can't connect to the remote share. You need to have symbols locally. A workaround for that now that we have a lot of newer machines is we can actually burn a CD, put the CD in the system, and load the symbols from the CD. Known issue just means that we've seen this break a lot. It could either be that they're currently trying to debug it and come up with a solution, or it could be that it's an actual bug and it's going to be fixed soon, or it could be a test issue and we just have to remove that test. There's a few different known issues that we have, but for the most part that just means that you can reclaim your machine and restart stress. Restart stress machine every day. We like this because of the randomization that the stress manager does. It does that one time. We like the machines to reboot every day and get a new set of tests, rather than running the same test. If you've been running the same test for 24 hours and nothing's happened, what are the odds that they're going to keep happening? We have other long haul stress clients that we do that on. So for the most part, we like everybody to restart stress daily, and that's how the majority of our lab rebuilds every single day and restarts stress. So here's another, based on the feedback of the last presentation. What do you as testers do when you have a break? So the process is going to be that we are going to, as the stress team, we're going to know when your machine is broken because of that stress manager application that had all the different colors and stuff and syncs up with your machine. We're going to determine if it's a break, if it's a known issue or a new issue. We're going to connect to your debugger and we're going to load the symbols. We're going to debug a little bit, and if we've been doing it long enough, we can see which are known issues and what aren't. So if it's a known issue, we'll let you know it's a known issue and how to go about fixing that problem. It could be maybe you need to update the drivers for your video card. That we get that a lot. If it's a new issue, we're going to file the bug. We're going to assign it to SP Break, and it's going to file a bug automatically. Once the bug has been filed, the developers are going to look at that, and they're going to connect to your machine and start debugging it. At that point, they'll either contact you via email or they'll just use the bug as communication. So what you actually need to do is monitor that bug. When we send you email in the morning and say this bug has been opened, you got to keep track of that and make sure that someone is looking at it. If it goes a day and no one's looked at it, you can email who it's assigned to and say, what's the status? I need this machine back. That's your responsibility, is to keep up on that machine. And then once the developer's done with it, you can reclaim it, rebuild it, start stress, whatever needs to be done. All right, so if you want to add a new stress test, this is kind of some of the guidelines we've come up with. Do not add your regression tests. This may be, you may have some automation that fully tests RAS, for example. We don't want that sort of thing. We want, like I was talking about earlier, well-behaved apps that always pass. Focus on what you want to stress. Like I said, if you want to stress a client dialing up to a server via RAS, then just that should be your focus. It should dial up. You shouldn't try to do more than that. Stick to the basics to make the app reliable. Make sure it does stress the feature that you want. If you want it to actually successfully dial and it's sitting there and it's never getting to dial up, and it's always getting a busy signal, then you're really not stressing the part you wanted to stress, for example. Run it as a standalone app. This is like prior to giving it to us. We don't want, things that are going to break as soon as we add them to stress, because that's, it may break a few times for you, and now you take that across 400 systems, and that's going to cause a lot of pain. Once we actually add the app, you can actually set it. We'll set it to manual, and you can manually put it in and then run it along with stress, and that's usually how we do things. Or prior to us adding it, like it says in the last line here, that you can start your stress app and then start the real stress and see how they work together. Do this for a week or so before we actually put it in our mix. Server-based tests. This would be like, for example, RAS. If you were doing a RAS server, how are you gonna stress that? The way we actually did this for RAS is we added a RAS test for clients that basically dialed up to our server, and we monitored all the calls on the server. So by adding it to stress, we got a lot of clients doing their work, but then we also got all those clients to dial one machine, so that caused a lot of stress on our server. You want to make sure that you have minimal downtime, because if you're going to have all these machines contacting your server via whatever mechanism, you don't want to be down for a long period of time, because then you're going to get a lot of failures that really aren't failures. You want to make sure you get the right load. I guess you don't want to overload the system, you don't want to underload the system. If you're only getting one call per day, that's really not stress. And if you're getting, a million calls a second, that might be a bit too much. I mean, it kind of depends on the specification of your component and what its kind of boundaries are of what it's supposed to be able to handle. And like I said, if your server's down, you don't want the clients to go berserk. If they're going to all of a sudden start leaking memory or something like that because something's down, that's going to cause really bad results in our stress. And then, is this workstation stress or component stress? Next, we're going to talk about what component stress is after a few minutes. Long haul stress is we try to load up our machines and run them for a long period of time. There's client and server versions of this. Client is just regular stress run for a long duration of time. We try to run it as long as possible. We do this in a lab. This long haul stress is more the server side. Like, for example, RAS. You may want to keep your server up for 2 weeks without having to reboot, or take a million calls without having to reboot, or something like that. It's part of our service pack release criteria. We have certain, depending on what time we're on, this last bullet here where it says B1, that's beta 1, beta 2. Release candidate, and RTM. And for each of those, we have a certain number of days we want a server to be able to remain up. So for beta 1, let's say if we were in that, I would be monitoring these machines and make sure that every machine was up for at least 7 days. As long as they were up for 7 days, then I'm okay to sign off. For RTM, when we're actually going to release this to the world, we want the machines to be able to go up for 21 days, without having to reboot for any reason. And this can be different from component stress. We should be modeled more around real-world environments. Stress, as you saw, or I guess I don't have any pictures of it, but the stress of the client is all these different apps running. That's not really a real world, you're not doing that at home where you're running 40 different apps all at the same time. Long haul stress is if your machine is supposed to be a RAS server, for example, you're just going to be accepting RAS calls. You're not also going to be, playing streaming audio and so other things that may take your bandwidth. You want to dedicate that machine. So that's kind of what long haul is doing. You're going to dedicate it for what its purpose is. It's not a multi-purpose system. Should vary your usage as much as possible. If you can maybe make your clients not call, let's say if it was RAS again, if you're not calling on the weekends maybe, or vice versa. Try to mix it up a little. Real world's not always consistently, 100 calls per second. It's going to vary depending on what time of the day it is and where you're at, that kind of thing. You want to run with driver verifier, app verifier, page heap. I don't know if all these have been discussed, but these are different tools that are going to help catch issues that you wouldn't normally catch. How much stress for your long haul machine? You want to have like an 80% load, but again, this is kind of dependent on what is considered a maximum load for your particular component. You can add more clients, remove clients, that kind of thing to increase or decrease the load that you have. The CPU load, you want to watch that because maybe you may have something that's not a very CPU intensive server, and so if it's really spiking, then you may have some issues, or vice versa. If you have something that takes a lot of CPU, you want to watch that and make sure it's actually taking a lot, because otherwise you may not be stressing your system as much as you thought. Eliminate bottlenecks. This could be network bottlenecks. This could be other apps running on this system. Whatever. You want it to be as dedicated to this component as possible. What kind of things do you need to monitor? Your component-specific data. Like for RAS, how many successful calls, how many failed calls, how much data transfer, all this kind of stuff. Resource usage. You want to look at your memory, your handles, etc. Event log messages. You want to make sure there's no unclear event log messages that you're receiving. And you want to keep track of this from pass to pass. You want to know that if in beta you saw all these event log messages and they're expected, are you still seeing them in beta 2, or are you getting new ones? Number of clients, connections accepted, packets transmitted, received. That's kind of the basic thing I was just saying with successful calls and that kind of stuff. If you have a reporting server, scam server, you want to watch that. That's to make sure you're syncing up and keeping track of your accurate data. And the clients, you want to make sure how they're doing and if they're breaking. Things to take care of stress in general. The debugger is very important. Like I said, if we can't connect to your debugger, can't debug your machine, then you ran stress for no reason really, and it's not helping us determine if we have any bugs. Symbols. We need to have symbols not only local to your stress client, but accessible via the network. Via the network's more the server team's responsibility, which I take care of, but from your client side, you want to make sure you have them in case you break in a user mode break and don't have network access. User account. There's a user account for long haul that we actually use to monitor your system and check it out for some health. If you have long haul, that you'll get more detail on that when you go through that training. But there's also, on your debugger, you need to enable the guest account so that we can remote in. Otherwise, we're going to get an unknown username or bad password. Connectivity to Corp. This is how we do all our work around here so that we can communicate, because we have people clear across the campus, running stress or whatever. We need to connect to them, and we need to go over Corp. For long haul, you want to make sure that your machine is registered and showing up in the data as it's supposed to. There's a reboot log for long haul, which when you reboot, it's going to pop up and ask you why, and we keep track of this data. Is it actually what it's going to do is once your system comes back up, it's going to pop up. It's in the startup basically, and that way you can tell us why the machine rebooted. Was it, you had some new stuff the new service pack you had to install. That's okay. Was it because the machine broke? Stuff like that. We need to keep that. The long haul stress report, again, that's kind of going along with registration. We need to make sure that your stress is being reported accurately, and never reboot during those. Mostly it's during the test pass. Like we say, if we want 21 days, then your machine needs to stay up for those 21 days. Once we're done with long haul, then you can upgrade or do whatever. So you never want to reboot as much as possible. Any questions? These are some links that can hopefully help you. The SP Stress is our main reporting site that we use. WinSE Test has some general guidelines on just different testing questions, methodologies, that sort of stuff. Stress Web is the core team's, the team that's working on server and long and SP2 right now. HTTP DBG, that's where you would install your debugger. And you could always email SP Stress. Does anybody have any questions? Yes?
Who provides the test applications which you have mentioned in Test Manager?
So the question is who provides the tests that are in the Stress Manager? The tests are provided by component owners. As the Stress team, we're responsible for keeping tests. So if this was day one and we just created Stress, there would be no tests in it. And then someone over here who tests, directory services may say, I have this thing that I run every day, and I would like a lot more machines to run this on a daily basis. They give us their test, and now we allow that to run. So it's basically the component owner's responsibility. We don't do any test creation from the Stress ownership side. It's the component owner. You know the component, you know how to stress it the best. So that's where we get our tests from.
Do we have any checklist which says that for a particular component you need to run so and so test?
I think the question was, do we have a checklist that says for each component what should be stressed? I don't think there's a generic answer for that on what should be. I mean, there are some generics. If you can stress, you try to reach your boundaries, whatever that may be. For RAS, and maybe a million calls at one time. That's a stress. But I mean, it kind of depends on your component, and what your component is really designed to do. If it's a networking component, you really need to stress some network stuff. There's no real answer. There's no real concrete answer for every single component, I guess. It kind of depends. Once you get the component, you kind of see the areas that could be automated very easily to test on every single system, and they could just keep running. And that's kind of how it is. It's never really just here's what you should stress.
Is there any difference between scalability tests and stress tests?
Any difference between scalability tests and stress tests? Yeah, I mean, stress, I guess, I'm trying to think of an example, I guess. So you give me an example of scalability and what, like in a component you may own, of what you mean by scalability.
The other day, one speaker was telling about a problem which happened in Bank of America, like when they were giving print requests from 8,000 machines to a server, then it gets flashed.
Okay, so the example was a server getting too many print requests, and how the system should be able to scale at that point to handle that. I guess if you consider it in that respect, then yes, they are the same, because in stress you're going to try to get 8,000, if you know that's your limit, or you know what I mean, you're going to try to get the most print requests in this example at one time, or over a given period of time. So that will find scalability issues, but they are different. I mean, scalability and stress aren't necessarily the same. I mean, it'll help you find your scalability problems, but it's not for scalability, I guess. You know what I mean? I don't know how to explain it any better than that, other than it. I mean, they are related, but it's not the only way you want to test it. It'll help you reach it, but you should also have other scalability tests.
So is the
it applicable to the GDR workstation? Is it something similar, or is it only specific to the service packs?
The question was, is this only related to service pack stress, or is it also related to GDR and workstation stress? So they are all the same. The stress suite is identical. It's just a matter of how your system is configured prior to. Workstation stress is service pack stress, basically. We run that in every machine, but GDR stress, you'll go back. You're not going to be on the most current service pack that you're testing. So you may be testing that right now for Service Pack 5 for Windows 2000. We're not going to put on SP5. We're going to put on Service Pack 2, and then we're going to install everything from Windows Update and install all the GDRs, and then we're going to run stress. I just got done working on a new reporting site for that today, in fact. But it's the same stress that's being run. It's just a matter of how you configure your system first.
So when it comes for the SP, you run it for every milestone, or like for example, all the bucket tests, they are run for every milestone for an SP. Is it the same thing with this stress?
The question is stress run for every milestone, like bucket testing? Stress is more focused on during a milestone, say beta 1. We may be trying to reach our 300 machines per night goal, but stress can be run at any time. I mean, there's always people running stress, but it just gets more focus during the milestone. So you could say that it is gauged around milestones.
Because the reason I asked, because for most of these bucket tests, you could see the result in SPRES as per the milestones. What is the goal at goal targets? What is the target? This seems to be separate from the bucket testing. I'm just trying to see where does this fit in?
Okay, he's asking like for results on which side did you say was it? SPRES. Stress does have to log. We do have to sign off as well. When it comes time for say beta, if we're signing off on beta, we have to sign off. But we're not logging as much data as a component test would be, bucket test. Stress is one of the options, I think, in a lot of the bucket tests. Did you run component tests, component stress? But we also are signing off, and that's more based off of we know we hit our 300 machines for a week or whatever it may be that our goal is. But we don't necessarily keep all of the logs. I mean, our breaks database is kind of our log. How many breaks did we have and that kind of thing. But it's not as much as, for testing a component, you have your logs from your regressions, and you may put those on a certain share. We don't really have that for stress so much, but we do have to sign off at the milestone, just like everybody else does. Yes.
While running the stress test, is this blue screen or a crash the only indication of a bug, or you are looking at some other parameters like 100% CPU utilization or?
Pretty much, the question is a blue screen or a crash the only indication of a bug? What we look for is anything that causes your system to break into the debugger. That's what indicates a bug. This could be user mode. You could have an access violation. You could actually have a bug check. Those are going to break into the debugger. There are a lot of times where your machine may hard hang and not actually break into the debugger, and at that point there's not much we can do. So if it's not broken in the debugger, we don't know that something's wrong. So no, this is not a way to check out the CPU utilization, because a slower machine is going to be bogged down by 5 applications. A faster machine can run 100 and still be okay. So looking at such things as CPU utilization is not a good idea here. It's more, did it break into the debugger is what we're looking for. Anything else? I think I'm done.